The Park Avenue Ultra Sedan is the ultimate expression of a premium American luxury car. Designed to become the new standard for quiet, smooth-riding sedans, Ultra offers a number of styling, comfort, and luxury features that distinguish it from other automobiles. Its distinctive all-leather seats were created by famed Italian automotive designer Giorgio Guigiero, his first effort for an American luxury car builder. In addition to offering the richness of leather and a designer treatment, both front seats also provide 20-way power control for optimum seating comfort. The Ultra seat is based on the Hancock 3-motor system. The 3 motors provide basic 6-way adjustment through switches located in each front door armrest. The controls for Ultra's additional power-adjusted features are located in the console lid. By touching these controls, the driver and passenger can adjust the headrest up or down, recline the seat, or increase or decrease the air pressure in the headrest, lumbar support bladder, and thigh support bladder. Other special interior touches include a unique leather steering wheel, leather trim on the glove box, and simulated burled elm trim on the instrument panel and on the doors. Exterior styling features include a grille crafted solely for Ultra, a distinctive two-tone finish with a silver lower body accent treatment, and unique tail lamps. On the road, Ultra provides a smooth, quiet luxury car ride thanks to its specially tuned Dynaride suspension and the use of premium insulation throughout the passenger compartment. Standard equipment includes P205 70R 15 all-season radial white-wall tires on highly polished aluminum wheels. Also standard are ABS anti-lock brakes. And for owners who select the vinyl roof option, Ultra also offers the elegance and privacy of a limousine-style rear window. Buick Park Avenue Ultra. Now that we've highlighted some of Ultra's unique features, let's take a closer look at the 20-way power seats. Basic 6-way adjustment is provided by the Hancock 3 motor system, which is used on other Buick models. The heart of Ultra's additional seating comfort features is the seat control module located in the driver's seat. When a selection is made on the seat control switch in the console lid, the switch supplies voltage to the corresponding input on the seat control module. The module then supplies voltage to the appropriate adjusting component. Each seat incorporates a recliner motor, a headrest motor, and a solenoid valve assembly that controls air pressure to the various air bladders. A seat air pump assembly in the driver's seat supplies air pressure to both seats, and a lumbar control module, which is also located in the driver's seat, controls the inflate and deflate operation of the seat air pump assembly. Each seat incorporates 3 air bladders. A 3-compartment bladder in the seat back provides lower back or lumbar support. One bladder positioned at the front of the seat cushion provides thigh support. Another bladder located in the headrest fine-tunes the front-to-rear adjustment of the headrest. When the driver or passenger opens the console lid to make an adjustment, an electroluminescent lamp lights the seat control switch. When the lid is opened, the console lid switch closes. If the ignition switch is on, an inverter within the seat control module converts battery voltage to approximately 37 volts AC and supplies it to the electroluminescent lamp, which requires this higher voltage to operate. The selector light indicates which seat is activated. When the driver's seat select button is pressed, the seat control switch momentarily applies battery voltage to the seat control module. The control module grounds its output to the selected indicator light, completing the light circuit. If the passenger seat is selected, voltage is supplied to a different terminal of the seat control module. When a reclined forward adjustment is requested on the driver's seat, the seat control switch applies battery voltage to the seat control module. The control module then applies voltage to the recliner motor. Note, the recliner motor is grounded at terminal 16. When a recliner back request is made, the seat control switch applies battery voltage to the seat control module. The seat control module also applies battery voltage to the recliner motor through terminal 16. The recliner motor is grounded through terminal 15. So the current flow is reversed and the motor runs in the opposite direction to move the seat back down. If a headrest up adjustment is requested for the driver's seat, the seat control switch applies voltage to the seat control module, which then applies voltage to the headrest motor through terminal 13. Note that the headrest motor is grounded through terminal 14. When the headrest motor receives voltage from the seat control module, it moves the headrest up to make the requested adjustment. When a headrest down request is made for the driver's seat, the seat control switch applies battery voltage to the seat control module. The seat control module then applies battery voltage to the headrest motor through terminal 14. The motor is now grounded through terminal 13, so it runs backwards to move the headrest down. The seat air bladders are inflated and deflated through the individual solenoid valve units in the solenoid valve assembly. 5 solenoids are used for each seat. 1 for the thigh bladder, 1 for the headrest bladder, and 1 for each of the 3 compartments in the seat back bladder. When the driver or passenger presses the inflate or deflate control for any of the air bladders, the seat control module applies battery voltage to the appropriate solenoid in the solenoid valve assembly. The solenoid then opens the air passage joining the air bladder to the seat air pump assembly. At the same instant, the seat control module applies battery voltage to the selected inflate or deflate relay within the lumbar control module. The module provides a control signal to the seat air pump assembly. For an inflate request, the air pump supplies air pressure through the solenoid valve to the air bladder. For a deflate request, the air pump pumps air from the bladder and vents it to the atmosphere. The reference manual that accompanies this program provides complete troubleshooting and component replacement procedures for the Ultra seat. The system check chart provides instructions for performing a run-through of all seat functions. If this check identifies any operational problems, the symptom diagnosis guide suggests various component electrical tests to help determine if the problem is due to a defective component or the result of a damaged wire or connector. Here are some of the major tests. The seat control module connector can be tested to verify that the control module is receiving battery voltage. The solenoid valve assembly connector test verifies the solenoid valve assembly is receiving battery voltage through the seat control switch when air pressure adjustments are requested. The lumbar control module test checks the electrical circuit for the lumbar control module and the seat air pump assembly. To determine if the seat control module is at fault, the module can be bypassed with fuse jumpers. If the function is operative with the jumpers in place, the seat control module is defective. The seat control switch can be tested to verify that it's providing battery voltage to the proper components in response to commands. The tests may indicate that a defective component must be replaced. The seat must be removed in order to replace some components, while others can be replaced with the seat in the car. Due to the unique design of the Ultra's vinyl roof and limousine-style rear window, the vinyl and foam must be replaced if the rear window glass requires replacement. This is due to the fact that in order to remove the rear glass, it's necessary to remove the fiberglass cap that encloses the rear window. During this procedure, the vinyl may be damaged. Also, air bubbles may form and read through the vinyl. Therefore, the vinyl and foam are always replaced if the window glass is replaced. The Know-How reference manual details this procedure, but let's look at some of the more important steps. During removal of the vinyl, the back glass welt lacing must be removed. Because this lacing is held in place by a urethane bond, the lacing will be damaged during removal, so it must be replaced. When removing the lacing, use a plastic scraper to break the urethane bond. Before the vinyl can be removed, the Ultra emblems must be removed from both sides of the roof. These are also damaged during removal and must therefore be replaced. With all emblems and moldings removed, the vinyl can be removed. Pull the vinyl away from the foam pad material that serves as a base for the vinyl. Two foam pads are used. The pad under the vinyl is a thin one that can be removed with a rolling action. A thicker foam pad is affixed to the roof of the car. The most effective method of removing this pad is to cut channels into the pad. Then, pour an all-purpose cleaner into the channels. After a few minutes, the solvent loosens the adhesive backing in the vicinity of each channel. This makes it easier to remove the foam. If necessary, use a plastic putty knife or scraper to remove the foam. But it's important not to scratch through the paint during this procedure. To remove the cap, the 13 screws attaching the cap to the roof must be removed. The cap is attached to the glass by 6 metal tabs. The tabs are riveted to the cap and bonded to the glass with urethane. If the glass is not broken and is not being replaced, remove the rivets before removing the cap retaining screws. The cap can then be removed, but the tabs will stay in place on the glass. And the cap can be riveted to the tabs during the installation process. If the glass is broken, then the tabs can be left on the cap and the broken glass can be pulled away from the tabs. Thoroughly clean the tab mating surfaces before the tabs are urethaned to the new glass. The roof and the cap must be thoroughly cleaned to remove all particles of the old foam material before the new foam pad and vinyl are installed. This is critical to preventing any high spots from reading through the new vinyl. If the old foam will not separate from the cap, it may be necessary to replace the cap. Also, any bare metal must be primed to prevent rust from developing under the vinyl. Two new foam pads must be installed before the vinyl is applied. The first pad must be centered on the roof, trimmed, and all the air bubbles must be worked out once it is properly positioned. This must be done quickly because the adhesive on the foam sets up in about 1 hour. To install the pad, first position it on the roof. Then remove the adhesive backing from the rear half of the pad. Install the rear half on the car. Repeat this procedure for the front half of the pad. Then, trim the pad with a razor blade as necessary, but be very careful not to damage the paint with the razor blade. Using one of the old Ultra emblems for a pattern, mark the outline of the emblem on each side of the roof. Then cut this outline into the pad to create an indentation for each emblem. Place duct tape over the rear corner welt retainers and the cap to pad seam. This will help provide a smooth base for the second pad and the vinyl. The second pad, which is only about 1/10 of an inch thick, helps provide a smooth base for the vinyl material.